This is Pre-Calculus, Chapter 3, Section 4, where we're looking at all zeros of polynomials, including the repeated zeros. So in this problem, we have a cubic that we're trying to find all zeros. And we ask ourselves, there's 5 different things I want us to look at. And one is we look at this cubic and say how many zeros are there, counting all zeros, real, non-real, repeated zeros. There's a total of 3 because it's a third-degree polynomial. We can list, if there are any real rational zeros, we know we can find those by looking at the factors of the constant coefficient, the -2, divided by all of the factors of the leading coefficient, which is 1. And when we look at all those combinations, we only get 4 numbers, with 1, -1, 2, and -2. The next thing we need to do is test each one of those zeros to find out if it actually is a zero. We do that just by plugging each one of them into the function. And when we plug in 1, we don't get 0. When we plug in -1, we don't get 0. When we plug in 2, we still don't get 0. We're getting low on possibilities here. We plug in a -2, and thankfully we get 1 0. So at least 1 0 is a rational zero. We next move on to this where we're going to use that 0 in synthetic division, and we'll use this to help us find all the remaining zeros. And the way we do that is we do the synthetic division, and of course we got 0 remainder because we knew that it was going to be it truly is a 0, so we should have no remainder. And then we have these 3 numbers here, 1, 2, and -1, and what those are coefficients for the next degree lower. Since this was a third degree, this is now a second-degree polynomial. Since it's a second-degree polynomial, we can use the quadratic formula to find the other 2 zeros, and then we would have all 3 zeros. So using the quadratic formula and simplifying, we get -1 plus or minus √2, which gives us the 3 zeros are -2, and then -1 plus √2 and -1 minus √2.